Have you ever wondered why your favorite app crashes the one time you actually need it, but the world's phone systems or WhatsApp stay online for years without a single reboot? It's not because their code is perfect. It's because their code is designed to fail.
Most programmers live in a constant state of fear. They build software like it's a fragile glass sculpture. If one tiny piece cracks, the whole thing shatters. Then they're stuck at 3 a.m. on a Sunday trying to glue the shards back together.
But back in the 80s, a group of Swedish engineers at Ericsson looked at this perfectionist logic and said, "Nein." They created a language called Erlang, and its secret to being the most reliable code on Earth? It's not being perfect. It's being a total nihilist.
Huh? Today, we're looking at the strict logic of the language that powers WhatsApp, Discord, and the phone system you're probably using to subscribe to this channel.
Ericsson had a 9 nines problem. They needed their phone switches to stay online 99.9999999% of the time. To put that in perspective, if your car had that kind of uptime, you could drive it for 30 years, and it would only stall for exactly 1 second. Most languages couldn't do this. If a C++ program encountered a weird edge case, it would core dump and die. And in the telecom world, a core dump meant an entire city couldn't call their moms to say they'd be late for dinner.
High stakes.
Joe Armstrong and his team, they realized that trying to prevent every single bug is a fool's errand. Humans are messy. We write bad code. It's what we do.
So Erlang's logic is simple. Let it crash. He uses something called a supervisor tree. Think of it like a corporate hierarchy, but actually efficient. You have a worker who's doing millions of tiny individual tasks, and that worker hits by a bug and explodes. The supervisor doesn't panic. It doesn't send an angry email or hold a performance review. It just says, "Oh, Dave's dead. Here's a new Dave," and restarts the process in a clean state in milliseconds. The rest of the system never even felt the blast. It's lizard logic. Lose the tail, keep the lizard.
But here is the part that makes other developers weep with envy. Hot code swapping. Normally, to update an app, you have to turn the server off, upload the new code, and turn it back on. In Erlang, you just slide the new code in while the engine is running. Basically, new and old code are running side by side, and users are transferred from old code to new. It's like changing the tires on a Formula 1 car while it's doing 200 miles per hour. This is how phone switches stayed online for decades without a single reboot. They just patched the logic while people were mid-conversation.
Magic.
If you think this is just old tech for landlines, ask the guys at WhatsApp. When Facebook bought them for $19 billion, they only had about 50 engineers for 450 million users. That's a ratio of 1 engineer for every 9 million people. In any other language, that is a suicide mission. But because of Erlang's strict logic, the language handled the scaling, the crashes, and the millions of concurrent connections. The engineers just had to make sure the send button worked. As we head into 2026, Erlang is having a bit of a midlife crisis, but in a good way. Its isolated process logic is perfect for managing swarms of AI agents that need to talk to each other without causing a global blue screen of death. The lesson of Erlang? You don't need to be perfect to be unstoppable. You just need a really good plan for when things inevitably go wrong. That's the logic. Don't forget to subscribe and comment. I'll see you in the next one.